All right, so for this first problem, at first glance, it can look really chaotic. It can look like there's a ton of stuff going on, and in some ways there is a lot of stuff going on, but the problem itself is actually fairly simple. Because when we go to simplify it, we're just looking to see anything that is being multiplied into both the top and the bottom, because if it's multiplied into the entire top and the entire bottom, we can cancel it out. So for instance, notice I have an x plus 8 on the top and an x plus 8 on the bottom. Those are going to cancel out, because you'll notice that x plus 8, it's being multiplied by everything else. All the other operations with it are multiplication there, so we can cancel it for that reason. All right, so as we look down the list, we're just looking to see is there anything else that we can. Like the x minus 1 on the top here, does it have a partner on the bottom? Yes, so we can cancel those out. The x minus 2 on the top, does it have a partner on the bottom? Well, there's an x plus 2 on the bottom, but not an x minus 2. Am I allowed to cancel those out? No, they're too different. The fact that one is a plus 2 and one is a minus 2, no, we cannot do anything with those. The plus 5, is there an x plus 5 on the bottom? Yes, there is, so we can cancel out that pair. All right, so already we've simplified this down quite a lot. But one thing that you notice I kind of skipped over here was this bit. And we can simplify that as well. But this actually goes back to more the previous skills, the old skills you used way earlier in the year of just simplifying that kind of a fraction. So like 15 over 25, what can I divide both of those by? 5. And so that's all we're going to do with the 15 and the 25 is divide both by 5. So that's going to give me a 3 and a 5. Then I look at those x's. I have x to the 5th on the top and x cubed on the bottom. Well, one way to do this is with the basic rule, which is subtract the exponents. 5 minus 3 will tell me 2. So it's going to be x squared left. The other way you can think about it is that I have 5 x's all multiplied together on the top, and I have 3 x's all multiplied together on the bottom. And again, I can cancel out anything multiplied into both the top and the bottom, which in this case would mean canceling out 3 pairs of x's, again leaving 2 x's behind. That is x times x is x squared. Now notice there were more x's on the top than on the bottom, and that's why the x squared is on the top. If this part was upside down, so we had more x's on the bottom than the top, then that x squared would be on the bottom. All right, and then looking to see what else I hadn't yet canceled out, the x minus 2, it's going to be on the top, so it's just going to be x minus 2 on the top like that, and the x plus 2, it is left behind on the bottom. So then this is our final answer. Now as you take a look at this problem, obviously the structure of this is very different from the last one. I got a whole bunch of stuff added together on the top and bottom instead of a whole bunch of stuff multiplied. Now, does that really change anything? Am I allowed, for instance, to cancel out those x squareds? Well, remember, for us to be able to cancel something out of both top and bottom, I have to be able to divide it out of the entire top and the entire bottom. Can I divide these other terms by x squared? No, I can't. And so we actually cannot cancel out those x squareds either. And the last problem that we did, all those parentheses there meant all those different pieces were being multiplied. The addition, that changes things up quite a bit. And so when it's added in there, it just means we can't just start canceling willy-nilly like that. But we can make this into a form that will allow us to do something to it. Remember the last one, it was basically a really big factored form. Well, as you take a look at this one, is that quadratic factorable? Yeah. Remember, to factor the quadratic, we look for the two numbers that add to the middle number, multiply to the last number. What adds to 5 and multiplies to 6? 3 and 2. So this is going to become x plus 3 times x plus 2. And this is all going to be over the bottom. Does the bottom factor? Are there two numbers that add to 7 and multiply to 10? Yes, there are. And so that's 5 and 2. So we're going to do x plus 5 times x plus 2 And once we've done that, we can now take a look at our work here and now look for something that is multiplied into both the top and the bottom. What do you see multiplied into both the top and the bottom here? Hopefully, you're noticing that x plus 2. That means those are going to cancel out, leaving just the x plus 3 on the top and the x plus 5 on the bottom. That then is our final answer, is x plus 3 over x plus 5. And again, I cannot cancel out the x's here because I can't divide every term by those x's. I'd have to be able to divide every single one of those by the same thing. And you notice there's nothing that actually goes into all 4 of those here. You'll notice that this problem basically was the same kind of idea as the last one. It's just integrating our factoring skills first. So whenever you see an expanded polynomial like this, and you're going to try to simplify a rational expression, basically a fancy fraction, when you go to simplify that, factor it first. Now, as you start this problem, is there anything I can divide out of every single term on the top and the bottom right now? No. Because there's nothing, for instance, that would go into both 10x and 55x and like 48. There's nothing that goes into even those 3, let alone all 6 of them. So we are going to want to factor it first. Now, when factoring this one, okay, some of you might have started by figuring out what does a times c equal, because there is a number in front of x squared, but notice you don't have to here. Always look to see is there something you can factor out of every term of the quadratic at the start. And like if I just look at the top, there's a 2 there, I can factor that 2 out. Now notice, this is not the same as like reducing the fraction by 2. I'm not dividing everything on the top and bottom by 2. I'm just putting the 2 out of every term on the top. So it's still there, it's still sitting there. It'd help if I remember to divide the 10 to the 48 by the 2 though, wouldn't it? And so that would actually be a 5x and a 24. There we go. And then on the bottom, notice there, I can actually divide all those by 5. So do that. Start by pulling the 5 out of that quadratic. All right, having done that, we now need to kind of look ahead, figure out what are our next steps going to be. Question here. I see 24 appearing in both top and bottom. Am I allowed to go ahead and cancel those 24s out right now? No. Remember, I'd have to be able to divide everything on the top and bottom by that same thing, not just those 2 terms. So no, we cannot cancel out the 24s. In fact, right now there's nothing we can cancel out, but we can still try to factor it. Because you'll notice each of these 2 quadratics are factorable. So, factor them, please. Right, and so we factor the quadratics on the top and the bottom. Then we look for anything that's multiplied in both the top and the bottom. In this case, the x plus 8 is, and so those cancel out. And so now we're down to this step. Is there anything I can cancel out of both top and bottom at this point now? Well, can I pull anything out of the 2 and the 5 here? No. Am I allowed to cancel the x minus 3 with the x plus 3? No. And so for that reason, this is it. This is done. We can't take it any further than that. One little side note on this. This is as far as we're going on this today. Tomorrow I'm going to add one more step to the simplification process because there's actually a little caveat to this answer where it only works in certain conditions. Tomorrow we'll talk about those conditions. So just so you know, we're going to be talking about restrictions tomorrow, and that will have an impact on some of our answers. But for now, we're just focusing on kind of the process involved. So just so you know, that is on the horizon. All right, we're next going to take on this problem. which again is still going to use skills that we already know. It's just going to be a matter of bringing those skills back. All right, so to tackle this one, well, we got the x to the fourth in there this time. Although we can make at least one set of those a little bit simpler. Do you see which one we can deal with by just factoring something out of every term? Notice on the bottom here. Notice every single term has x's in it. For that reason, we can go ahead and factor some x's out of every term on the bottom. Specifically, how many x's can I pull out of every term on the bottom? Two of them. Exactly. I can factor x squared out of every term on the bottom. Now this isn't affecting the top yet, but at least I can do that at the start. Because that alone at least makes the bottom look a lot easier to work with. All right, now having done that, we certainly could go ahead and factor that quadratic on the bottom, but I still want to be able to figure out something to do on the top. Now the top we can deal with, but we might have gotten a little rusty because this skill doesn't come up nearly as often as the plain old quadratics on the bottom. The top, you'll notice here it goes x to the fourth, then x squared. This is that particular case where the first exponent is double the second exponent, and there's no x's in the last term. This is the one where we can still factor it using the same add to the middle number, multiply to the last number pattern, but the difference will be that each of our parentheses that we would normally just start with x plus or minus a number is going to be x squared plus or minus that number. So that means we need to figure out what two numbers add to negative 13 and multiply to 36. It's going to be a 4 and a 9, specifically a negative 4 and a negative 9. Now this is bringing us back a ways, right? This is one that we've gotten a little rusty on. So make sure you remember that if that first one is double the second, we can go ahead and treat it like a regular old quadratic there. All right, so I factored the top. Notice I can also factor the bottom as well, the x squared minus x minus 6. I can factor that as well. So the x squared is just going to be hanging out front of it. In this case, it's just going to be a plain old x at the start of each parenthesis. And I'm saying what two numbers add to negative 1 in the middle and multiply to negative 6 at the end. Well, that sounds like a negative 3 and a positive 2 to me. And so we're now down to this, which still isn't looking too promising. And yet, if you just keep going through these and simplifying one step at a time wherever you can, you'll be surprised to find that a lot of them will actually break down further than you might initially have thought. And this is one of those examples. Because you notice this x squared minus 9? That does factor more. This is that type where you're going to be able to break it down into x and x. And we're looking in this case for two numbers that add to 0 and multiply to negative 9. Well, the only way you add to 0 is if it's the same number, just opposite signs. So in other words, in order to get a 9, a 3 and a negative 3. So that x squared minus 9 factors to that. Are you going to be able to factor the x squared minus 4? Yeah. And when you get that factored form, be writing down everything. I know it can be tempting at a certain point to be like, well, I'm going to start cutting some corners. I'm going to skip writing all this stuff out or something like that. You will cause yourself problems if you try to cut corners here. Write out all the pieces that are there. Then we can go ahead and worry about simplifying this result. And we do have a number of terms, a number of parts here that are going to cancel out. We got x minus 3's out of both top and bottom. We got x plus 2's out of both top and bottom. But that's about it. I'm still left with an x plus 3 and an x minus 2 on the top. And all we're left with on the bottom is x squared. Basically, whatever we happen to be left with, that's what we leave. There's nothing magical about these problems where every time you'll be left with like a binomial on the top and the bottom. There's nothing that says anything will cancel out even. Although I will try to make it so that usually stuff will cancel out because it's at least more interesting that way. But once we get to here, is there anything else we can do? Well, do you see anything right now that you can cancel out of both the top and the bottom? Well, the only thing on the bottom is x squared, so that'd be an x. Can I take an x out of every term on the top? Doesn't look like it right now. I mean, we have an x here, but I can't exactly divide this whole thing by x, can I? So that wouldn't quite work. What if I multiplied it out and turned it into x squared plus x minus 6 all over x squared? Could I cancel out the x squareds then? No. Remember, if we're going to try to cancel something out of everything on the top and bottom, it truly has to come out of everything on the top and bottom. And I can't pull x squared out of 6, for instance. So, no, you don't need to do that then. So, do I need to expand it out into that form then? No. You don't need to. I mean, you can if you really want to. It's the same answer, of course. But you're perfectly fine just leaving it in the factored form. In fact, that'll often make your life a whole lot easier. So, by all means, leave it in factored form. Now that we've done just simplifying simple rational expressions, we can also do operations on the rational expressions, including multiplication to start with. A nice simple one to start here. Now, we're going to be multiplying fractions. In order to multiply fractions, we know we multiply straight across the top, straight across the bottom. But we have a choice to make here. We can either multiply straight across the top and just leave them in the factored form there, or I can go ahead and put it into expanded form as I multiply it out. Which one of these do you think is going to be easier to work with as we look to reducing this fraction that we'll get as an answer? I think the factored form, because in that last one we didn't we start by factoring it all? So you don't need to expand it, because if you expand it, the very first thing you're going to have to do after expanding it is you're going to have to factor it again. So leave it factored, which in a problem like this actually makes it very easy, because you notice that basically just means I write the two numerators next to each other and the two denominators next to each other. And then it's very easy, I hope at least, to simplify our resulting answer. I look for anything that I can cancel out of both the top and the bottom. In this case, that's the x plus 7s. And so we get a final answer then of x minus 3 over x minus 4. And you're done. Now, at the start of doing this problem, you actually have a couple choices about how to start, because one option is you could go ahead and start factoring your quadratics. Your other option is that you could take care of the division, because we know dividing fractions means multiplying by the reciprocal. And so you might have started either way, and both ways technically are valid. You could really start either way, but due to some of that work I alluded to earlier that we're going to go into tomorrow, you'll actually make your life easier in the long run if you start by doing the factoring part. And so that's the way I'm going to do it first up here. And so I factor every single one of those quadratics that I can. And in this case, they all factor. Then once I've done that, I'm going to rewrite it as multiplication by the reciprocal. This is going to be useful to us tomorrow, because being able to tell every single term that was at one point in the denominator is going to help us with that stuff that we go into. But for now, as long as you got to this step, whichever order you did them in, you're going to be okay. Now, the nice thing about multiplying the fractions is that, of course, multiplying just turns into multiplying. So the multiplying of the fractions up here becomes just multiplying all those individual parts of them down there. And yes, I do like to write it as a single fraction before I reduce. Some of you are going to be really fluid and you'll actually start reducing up here. That can work, and yes, that's technically okay. Just make sure you know what you're doing. All right, and now that I have my one big fraction, I look for anything that's common to both the top and the bottom that I can cancel out. Again, looking for stuff that is multiplied into both the top and the bottom. A lot cancels. In this case, we're just left with x minus 8 over x minus 7. That does not simplify any further past that, and so we are now done.